So in this lab, we got this kind of setup right here. There's going to be a cable that we know the capacitance of, we know the measurement. We're going to charge it to a certain voltage, so that way we know the charge that's in this entire setup. Then we're going to attach that to this whole setup, and then the charge is going to be distributed around. We're going to get a voltage reading here, and from that voltage we can rearrange these equations and we can figure out what the capacitance of the second thing is from that. Okay, so that's kind of the point of this lab. So the first step is we're going to take these little clips right here and we are going to plug it right in here. Okay, with that button, and boom, we set it to 30, just like that. Easy.
Separate the charge spheres.
So we got the electrostatics voltage thing. It's plugged into the comm. We plug it into this little device. We got 30 volts plugged in here.
Now is charged up to 30 volts. And then, so if I measure it with this, it should read 30, but it's not always exactly. Just touch these two together, and that zeroes it.
Nice.
Next,
so if I
plate
do this, okay,
31 volts.
So that's the voltage on the known capacitor. We'll disconnect it, and then when I touch this there to measure the voltage, that then allows charge to leave this and go into there. So the charge on this will decrease, which means the voltage across it will decrease, and so the reading you'll get there will be less than 31.
Okay.
Okay. So.
The voltage
17. So we did measure the voltage here, and we got 31. We have this little expression here that we're trying to measure the capacitance of the second capacitor. Then we did pull those things out. We got a reading of 17 on our electrometer. And then when we plug those into our equation, we get 100 picofarads. That's going to be the calculated version. Then we're actually going to do a test right now, and we're going to discover it's only 125. So we did get a little bit of error there. Got a little meter here. It's going to be measuring
So now these changes are
this for us.
These are actually
We've already done a calculation. And
for it to settle down. Okay, 124.9.
I'm going to connect the ground from the electrometer over here into the electrostatic voltage source over here. That should work. Okay, and then we're going to stick this into the electrostatics, into the 2000 port. Awesome.
So this one.
So the one with the red tip, we're going to keep track, because this is the one that we're going to charge up. We're going to put it on that side.
Just gonna hold this, grab both of them. I should ground it pretty nice.
I guess we're trying to ground this, and then we attach the clips, and then it should be 0. Yeah, that was good. Nice. Okay, and now we're going to start charging up by touching the magic wand to this, and then we're going to touch the left side. Boom, it's getting us some charge. Look at that. Let's try 21, 22,
And
23. So we're actually going to be measuring we're going to be measuring the volts when these things are about 10 millimeters apart. So they're 10 millimeters apart right here. We found a 66. We're pushing a little bit closer, and we're getting basically really small numbers as we bring down. So we'll look at the data in a second. And if we put it really far apart and go to infinity, what's the number that shows up? We're going to get 77 when this thing's pulled all the way apart. So that's kind of interesting. So we were able to graph the inverse of capacitance versus the separation distance. And as you can see, it creates a negative slope. In the beginning of this exercise, we were given a radius. So we were able to calculate the area of 25. This is for the plate, the plates that we were separating. And you know, based off of that graph, we found the slope of this, which is 1 over c divided by d, and then area of the plates are actually going to be this equation here. So when we rearrange that, and we found out that, well, based off our calculations, we got an area of about 23 centimeters, which is really, really close. It's only about 8% error. It's good calculations. So we're going to be putting these things 2 millimeters apart, and then we're going to slowly transfer charge from this thing onto that, and we're going to sort of count it. First charge was 4, then we got 7, and then we're going to get, then we got 9, and then we're getting, we're just slowly charging this up, 11. In the second graph, we were able to chart the voltage that the electrometer was reading for how many times we touched it with our magic wand to charge it. And we got a slope of about, 2.4, 2.5 or so. So because we had that particular slope of 2.5, then we could use this equation to figure out how many charges, like how much charge we added per touch. And then from there, we divided by the number, by the electron charge to be able to get this number. This is how many protons or electrons, probably the electrons, were transferred every time that we touched the ball.